Good morning students. Today we'll solve more numericals in chapter trigonometric functions. Okay. So now let us try more numericals. Now I will say toughest numericals. We have practiced more numericals based on the formulas which we have learned earlier. Now what we will do? We'll try to practice more toughest numericals now. Okay. So let us begin with trigonometric functions. Now the first I have in my hand is 2 cos pi by 13 cos 9 pi by 13 plus cos 3 pi by 13 plus cos 5 pi by 13 is equal to 0. We need to prove this. Okay. So for proving, now we will apply the formula. Now first of all, write it down LHS. 2 cos pi by 13 cos 9 pi by 13 plus cos 3 pi by 13 plus cos 5 pi by 13. Okay. So now what we will do, first apply the formula for 2 cos x cos y, that is cos x plus y plus cos x minus y plus cos 3 pi by 13 plus cos 5 pi by 13. Okay. Now here we got cos 10 pi by 13 plus cos minus 8 pi by 13. Okay. Plus cos 3 pi by 13 plus cos 5 pi by 13. Now we all know cos minus x is cos x, so we will use this. Cos 10 pi by 13 plus cos 8 pi by 13 plus cos 3 pi by 13 plus cos 5 pi by 13. Now, okay. So now we'll sort further. What we will do, we'll take this cos 10 pi upon 13 plus cos 3 pi upon 13. Okay. Here we'll take cos 8 pi upon 13 plus cos 5 pi upon 13. Okay. Now we'll apply the formula cos x plus cos y. We have divided like this. Okay. Now the formula for cos x plus cos y is 2 cos x plus y by 2 and cos x minus y by 2. Okay. By 2 we have, so we'll take the upper side, and 13 to 2 will be 26. Now plus we have, here also we can apply 2 cos 13 pi by 26 cos 3 pi by 26. Okay. Now what we can do, take reduce this. Okay. 2. Now we can take 2 cos pi by 2 common. We have cos 7 pi by 26 plus cos 3 pi by 26. Okay. Now we can see here cos 90 we know 0. So 2 into 0 into cos 7 pi by 26 cos 3 pi by 26. What? 0. That is what is required. Equal to RHS. So that is how we try to solve the numerical. We have used here, one thing we have used, cos pi by 2 is equal to 0. Two more identities we have used here, cos x plus cos y. Cos x plus cos y, that is 2 cos x plus y by 2 cos x minus y by 2. Okay. One more identity here I have used, that is 2 cos x cos y, that is cos x plus y plus cos x minus y. Okay. So we can see here we have used two formulas, that is two identities, plus we have used here, that is cosine is 0. So that is how, by using with the help of formulas, we can solve such kind of numerical. Now we'll try to solve the next numerical we have, that is second one. In this, what we need to do, sin 3x plus sin x. Okay, here multiply with sin x plus cos 3x minus cos x. Cos x is equal to 0. Okay, so this is what we need to do it. So we'll apply the identity here. So now first of all write it LHS, because we can't solve RHS furthermore, so we'll try to solve LHS first. Okay, so there is sin 3x plus sin x into sin x plus cos 3x minus cos x. Okay, now let us try to sort it out. We'll apply first the identity for sin x plus sin y. We will get 2 sin x plus y by 2 and cos x minus y, 3x minus x, 2x by 2, that is x, into sin x. Here we will apply cos x minus cos y, that is minus 2 sin x plus y by 2 sin x minus y by 2. Okay. So now what we will do, plus minus minus, so we will write here 2 sin 2x cos x sin x plus minus 2 sin 2x sin x cos x. So what will get? 0. That is what we need to prove it. Okay, so that is how we can easily apply the identity, and which identity I have used here will write here. Sin x plus sin y, that is 2 sin x plus y by 2 cos x minus y by 2, and we have used also cos x minus cos y, that is minus 2 sin x plus y by 2 and sin x minus y by 2. Okay, so these two identities, these two formulas we have used in this numerical to solve it. Okay, so now we'll try to solve the third numerical. Now the third numerical we have given is, that is cos x plus cos y का whole square plus sin x minus sin y का whole square is equal to 4 cos square x plus y by 2. Okay, now here we'll try to solve it out. First LHS. Okay, so we have cos x plus cos y whole square plus sin x minus sin y whole square. Now we'll apply the identity of a plus b whole square, that is a square plus b square plus 2ab plus 2ab. Similarly, I will apply here, that is a minus b whole square. So a square plus b square minus 2ab. Okay, so now I have applied two formulas we have studied in 9th class, that is in polynomial chapter. What we have studied is a plus b whole square, a minus b whole square, that is a square plus b square plus 2ab, and here a square plus b square minus 2ab. These two formulas we have studied in class 9th. Okay, so now we know the identity. Sin square x plus cos square x is 1. Sin square plus cos square x is 1. Now plus left with this. We can take 2 common. So what is there? Cos x cos y minus sin x sin y. Okay. So 1 plus 1, 2 plus 2. Now we know this is the formula for cos x plus y. Okay. So here I have used that identity, that is cos x plus y is equal to cos x cos y minus sin x sin y. Okay. So now we can take 2 here common. So left with what? Okay. Now I have left with this 1 plus cos x plus y. Now here I will use the formula which we have studied recently, that is cos 2x is equal to 2 cos square x minus 1. We have other formulas too, but here we will apply this. So now divide this by 2. So now I have left with cos x is equal to 2 cos square x by 2 minus 1. Now what we can do? Take this one to LHS, so we got 1 plus cos x is equal to 2 cos square x by 2. Okay. So now left with this 1 plus cos x. So I can write this 1 plus cos x is this. So we can write this 2 into 2 cos square x plus y by 2, because we have x plus y is x. Okay. So now 2 into 2 4 cos square x plus y by 2. Okay. For cos square x plus y by 2, which is required in the RHS. So finally we able to solve such kind of numerical using the identities and the formulas. Okay. So now we'll try to solve another numerical. Okay. So we have solved 3. Now we'll solve next one. Let us see what they have given in that. Okay. Now see, 4th numerical we have. Now 4th numerical, what is it saying is cos x minus cos y whole square and plus sin x minus sin y whole square is equal to 4 sin square x minus y by 2. Okay. So this is we need to prove. So now let us try this. First we will write LHS, that is cos x minus cos y whole square plus sin x minus sin y whole square. Okay. So now cos x minus cos y whole square plus sin x minus sin y whole square. Now we'll use the identity a minus b whole square, that is a square plus b square minus 2ab. Okay. Similarly here a square plus b square minus 2ab. Okay. Now So we have used here one identity, that is a minus b whole square. That is a square plus b square minus 2ab. Okay. Now see, cos square x plus sin square x 1, cos square plus sin square y 1 minus. Now take 2 here common, so I got cos x cos y plus sin x sin y. So here 1 plus 1 is 2, 2 minus 2. Now here the identity will be, that is cos x minus y. So you can see here the formulas are most important for us. Okay. So we can write here cos x minus y is equal to cos x cos y plus sin x sin y. Okay. So this identity I have used here. Now we can take 2 common, 1 minus cos x minus y. Okay. Now we will apply the same formula which we have applied in previous example, that is cos 2x. Here we will see, we will take this 1 minus 2 sin square x. Okay. Now divided by 2, you got this cos x is equal to 1 minus 2 sin square x by 2. Now we can see that we will take this that side. So I have 2 sin square x by 2 is equal to 1 minus cos x. So we have 1 minus cos x. So we'll use this one now. So 2 into 2 sin square x by 2. Okay. Here we have x this way. Okay. So now 2 into 2 is 4. So left with sin square x minus y by 2, which is required in the RHS. Hence proved. So by using the identities and the formulas, we can easily solve such kind of numericals. Okay. So now we'll try to solve next numerical. Now see what we have in that. So now in fifth numerical we have sin x plus sin 3x plus sin 5x plus sin 7x. We need to prove it to 4 cos x cos 2x sin 4x. Okay. So now let us try to sort it out. First LHS side. Let us see what is given. Sin x plus sin 3x plus sin 5x plus sin 7x. So now what we can do, we can add this, take this x plus 5, sin x plus sin 5x, okay, plus sin 3x plus sin 7x. Now we'll apply the identity. Sin x plus sin y, we'll got 2 sin x plus y by 2 and cos x minus y by 2 plus sin has also 2 sin x plus y by 2, okay, and cos we have x minus y by 2. Okay. So now we can see here 2 sin 3x cos 2x plus 2 sin 5x cos 2x. So we have here used two things. First one is sin x plus sin y. What is that? 2 sin x plus y by 2 and cos x minus y by 2. Okay. First thing. Second, we have said that cos minus x is equal to cos x. Okay, here we have used it. So two formulas we have used. Whatever we will use, we will write beside the solving numerical. Okay, beside solving the numerical. Now here we can take 2 cos 2x. What do we have? Sin 3x plus sin 5x. Okay. Now what will happen? We'll apply the identity again. That is sin x plus sin y. That is 2 sin x plus y by 2 cos x minus y by 2. Okay. 2 by 2 for this. Okay. So now I can say 2 into 2 4 cos 2x cos x sin 4x, which is required in the RHS. We already know cos minus x will be cos x. So likewise we solve numerical by using the identities and the formulas. So now we'll try to solve the next numerical. Okay, we have just solved 5 numericals. Now we'll try to solve the next numerical, which is, but let us see what it is asking. That is 6th question. Now we have 6th question. Now it is saying sin 7x plus sin 5x plus sin 9x plus sin 7x. 9x plus 3x. We have 3x upon cos 7x plus cos 5x plus cos 9x plus cos 3x is equal to tan 6x. Okay. So now let us see how we can solve this numerical. They want to prove LHS is equal to RHS. So now let us take first LHS. What is given is sin 7x plus sin 5x plus sin 9x plus sin 3x upon we have cos 7x plus cos 5x plus cos 9x plus cos 3x. Okay. Now we can apply the formula here. That is for the sin x plus sin y. We have 2 sin. We have 2 sin, that is x plus y by 2 cos x minus y by 2. Similarly, here also we'll see sin 6x and cos 3x. Okay. So now 2 cos x plus cos y, 2 cos x plus y by 2 cos x minus y by 2. So 2 cos x by 2 cos x minus y by 2 plus 2 cos x by 2 cos x minus y by 2. So we can see here we have applied two identities, sin x plus sin y and cos x plus cos y. What's it? 2 sin x plus y by 2 cos x minus y by 2. And here also 2 cos x plus y by 2 and cos x minus y by 2. So we have solved. Now see what we can take common from uppers, from the numerator. 2 sin 6x. Now what do we have? Cos x plus cos 3x. Similarly from the bottom I can take 2 cos 6x. Now I left with cos x plus cos 3x. Okay. So now we can see what is left with us. This is reduced. Now 2 also 2. Now sin 6x upon cos 6x is equal to tan 6x is equal to RHS. Okay. So we have used two formulas, that is sin x plus sin y and cos x plus cos y, to solve such numerical. Okay. So now we'll try to solve next numerical which is given. Let us see what they are asking about. So now we'll see about the seventh numerical. We have done 6 numericals now. We'll move to on the seventh one. So now the seventh numerical is, they're asking about sin 3x plus sin 2x minus sin x is equal to 4 sin x cos x by 2 and cos 3x by 2. Okay. So now let us try to solve it by LHS side first. So LHS, it is given sin 3x plus sin 2x minus sin x. Okay. So now we'll use that identity here, sin x minus sin y. Okay. So that is 2 cos x plus y by 2, and sin we have x minus y by 2. Okay. So here I have applied identity, that is sin x minus sin y is equal to 2 cos x plus y by 2 and sin x minus y by 2. Okay. So I have used that identity here. Now what we can do here is we can just use it like this. Okay. So now you can see here I have written sin 3x, that is 2 sin 3x by 2 and cos 3x by 2. Now what we can do is take 2 cos 3x by 2 common. Now what I have, sin 3x by 2 plus sin x by 2. Again I will use that identity, sin x plus sin y. So it will be how? Let us see. That will be 2 cos x plus y by 2 for x by 2. So by 2 it will be 2x. Okay. For x by 2, 2x. So it will be x cos x and sin x minus y by 2. So to x by 2. Okay. So I got this one. Okay. Sin x plus sin y. Sorry, sin x plus sin y is there, no? Okay. Here the identity will be different now. Sin x plus sin y, that is 2 sin x plus y by 2 cos x minus y by 2. So here I am using it, that is sin, and here it will be cos. So I got this. What is asked about, that is 4 sin x, then cos x by 2 and cos 3x by 2. Okay? That is what they have asked. So here I have used two identities, that is sin x minus sin y, okay, and sin x plus sin y. So that is how, by using these two identity, I have solved this numerical. Okay. So now we'll solve the next numerical. We have solved 7 numericals. Now we'll try to solve 8th one. We have the 8th numerical now. To find the value of sin x by 2, cos x by 2, and third one, that is tan x by 2. How to find? Now they are saying that tan x is equal to minus 4 upon 3 and x is in second quadrant. So second quadrant is x. So let us see how we will able to solve this. Now we know tan x is now x will be in second quadrant. No? So in second quadrant we can say like this. Okay? No. Second quadrant will be like this. 90 and here is 180. Let's say 180. So we can do that. Right? Okay, so what we have done. So now we can say we have tan x is equal to minus 4 upon 3. Okay. Now we have the identity, that is 1 plus tan square x is equal to sec square x. Now 1 plus this one we can find very easily, sec square x. So 1 minus plus 16 upon 9 sec square x, 9 plus 16.25 upon 9 is equal to sec square x. Okay. Now sec square x is this. Now sec x will be plus minus 5 upon 3 and cos x will be, we all know cos x is a reciprocal of sec x, so we got this 3 upon 5, but cos x is negative in second quadrant, so we'll use this. Okay, so now we have this. Now we'll use the formula which I have told you about cos 2x, that is 2 cos square x minus 1. Now if I divide this by 2, so I got 2 cos square x by 2 minus 1. Now 2 cos square x by 2 is equal to 1 plus cos x. Okay, so now I can use that identity. I will got 2 upon 5. Okay, that is 2 cos square x by 2. Okay, so now cos x by 2 will be 1 upon root 5. You can say root 5 upon 5. Okay, so this is what we got here. Cos x, that's plus minus, it will take plus 1. Now cos x we have, cos x by 2 we have root 5 upon 5. Now we will find the value of sin square x by 2 plus cos square x by 2 is equal to 1. So sin square x by 2 is equal to 1 minus cos square x by 2. That is, now you can see this numerical is totally different from the previous 7 which we have solved. Now we will see 1 minus cos value root 5 upon 5 whole square. So I got 1 minus 5 upon 25. So I got this value 25 minus 5 upon 25. Okay. So now I got this value, that is 20 upon 25. So now sin x by 2 will be root in this, so we'll solve root 20 upon 25. You can solve like this also. So we got root 2 upon root 2 upon root 5. So I got this one, root 2 upon root 5. Okay. So I got this value. We have in square root we have two values, positive and negative. We'll take the positive one. So sin x upon 2. Now try to sort it out, find tan x by 2. That is sin x by 2 upon cos x by 2. So we'll put the value root 2 upon root 5 upon cos we have root 5 upon 5. So if we use this 5 upon root 5. Okay. So that is upon root 5. So I got 5 root 2 upon 5. I got the value root 2. Okay. So you have seen the one which we have used in previous example also, cos 2x, by dividing the angle by 2. So I got this, and by this you can easily find these values. Okay. These are all tan x by 2, sin x by 2, cos x by 2 will be in which quadrant? First quadrant. So all will be positive value. Okay. So that is how we can find the value. Similar one, we'll solve next question now. We have, now they are asking about cos x. Cos x is given, that is minus 1 upon 3. And x in the, now they are saying third quadrant now. They are talking about the third one now. Okay. And the third quadrant is there. So third quadrant we can write like this. Okay. So it will be pi by 2 as in 2, and here I will write 3 pi by 4. Okay. So now this is, now they have given cos x, no? Cos x they have given. This is the ninth numerical I am trying to solve. Cos x is equal to minus 1 upon 3. Okay. Now, no need to take this. We have already have cos x. So, we can find very easily. No need to sort it out this. Now, we have cos x is equal to minus 1 upon 3. So, as it is in third quadrant, and third quadrant cos x or sec x is negative, only tan or cot is positive. Now what we can do, just take like this. So to find this value cos x, now we have minus 1 upon 3. Okay. So we'll put here, that is minus 1 upon 3 here we'll put. Okay. So we got 2 upon 3. Okay. So we got 2 upon 3. To cancel. So we have here 3 value, 1 upon root 3. Okay. So we can sort it out this if we want, root 3 upon 3. Okay. So we have got the value cos x by 2. Now putting here, we'll try to sort it out. Here we have 3 and here we have 3. So I got 3 and 9. Okay. So I got 9 minus 3. So I have got 9 minus 3, 6 upon 9. And the root, so we'll have the value, that is root 6 upon 3. Okay. So I got this. Now we'll find the value here. We got now sine I have root 6 upon root 3. And cos x we have root 3 upon 3. So now I will take this upside, root 6, here we have 3, and here we have 3, root 3. Okay. So now I can sort it out in this, root 6 upon root 3 and 2 root 3 upon 3. Root 18 upon 3. So I got this 2 root 3 upon 3 in my value. As they are in the first quadrant, so we can say that by 2, what we have? By 2, 90, and this one, 135. Second quadrant they are talking about. So in second quadrant we have sine x by 2 will be positive. Okay. Now they are talking cos x will be negative and tan x will also be negative. Okay. So that is how we can easily solve such kind of thing. Okay. Okay. So now we are able to sort it out. Cos x by 2 we have, sine we have positive, it will be negative, so it will be negative value. It's will be negative, but negative value. Okay. So like this we can solve. Now the third thing, now their third last numerical we will take today. Of that they ask about to find the sin x by 2, cos x by 2 and tan x by 2, and they have given sin x is equal to 1 upon 4. Here it is sin x. Now sin x is equal to 1 upon 4 and x is in the second quadrant. So it is in second quadrant, so we can write this pi by 2. here we can use, it is pi. Now it will be 4 and it will be 2. Okay. As it is in second quadrant, so it will be like this. Now let us try to find. Now they are saying they have given the value of sine, that is plus 1 by 4 now. Okay, so now they have given this sine x. So now we'll try to find the values. Let us see how we can do it. Now we have sine x, so we can easily find a value of cos x, that is sine square x plus cos square x is equal to 1. So cos square x will be 1 minus sine square x, that is 1 minus 1 upon 16, 15 upon 16 I have. Okay, so cos x will be root 15 upon 4, something like you can find like this. Now we have cos x. Now cos x is in second quadrant, so it will be negative. Now we'll find the value, that is 2 cos square x minus 1 is equal to cos 2x. So find the value. Cos x is equal to 2 cos square x by 2 minus 1. So cos x plus 1 upon 2 is equal to cos square x by 2. Now find the value. You can easily put here this value, 1 minus root 15 upon 4 upon 2 is equal to cos square x by 2. It will be 4 minus root 15 upon 8, and whole will go here to find cos x by 2. Actually this is a totally different question in terms of root. So we find the value of cos x by 2. Now we can easily find the value of sin x by 2. Okay, sin square x by 2 plus cos square x by 2 is equal to 1. Now we find the value, that is cos square x by 2. We need to find the value of sin square x by 2. So sin square x by 2 is equal to 1 minus cos square x by 2. Now we have 1 minus cos value, we will put here root 15 upon 8, and under root we will have square. So we will have 1 minus 4 minus root 15 upon 8. So 8 minus 4 minus root 15 upon 8. So I got 4 minus root 15 upon 8 here. Now sin x by 2 will be root. So here the value will be in more than 45 and less than this one. So we can easily say 70. So value may vary in second or third quadrant. No? So in second quadrant, as is there, x by 2 will be. So we find the value. Now tan x by 2 will be sin x by 2 upon cos x by 2. 4 minus root 15 upon 8 upon 4 minus root 15 upon 8. So by solving this, you will get 1. Okay. So if I am talking about the third quadrant, if I say second or third quadrant, cos will be negative. Okay. Cos will be negative here. Cos will be negative. And sin, if it's talking about quadrant, so you can put like this. 3 pi by 2 I am using it. No, it's pi. No, it's pi by 2. Yes, it will be pi by 2. Okay, because I have used just 2 pi by 2. So it will be in first quadrant. So all will be positive. Okay, all will be in a positive way. So we will try to find the value this way. Okay, sin was the first quadrant. So easily we can find and solve such kind of numbers. Thank you.